Wonderful. So thanks very much for the invitation to be here in Israel. It's fantastic to be here. It's great to meet a lot of you at dinner last night as well. I think that some school is just a wonderful opportunity for all of us to interact together and learn from one another. So really excited about that conversation, continuing that conversation today and tomorrow. So what I wanted to start off in my first lecture is to think a little bit more about economic geography, the determinants of the location of economic activity in space. And so I wanted to start out by just kind of framing where the material I'm going to cover connects with this sort of longer intellectual tradition. And so I'm going to start off connecting back to the work in Paul Krugman's Nobel Prize citation of developing theoretical models to think about the location of economic activity in space and providing microeconomic foundations for the notion of agglomeration. And then move forward into recent quantitative models of economic geography, which sort of build on that theoretical literature. But the goal of these quantitative models is instead to connect directly with the data we observe. So real world data where we have many, many regions, they may be asymmetric in terms of their productivities, their amenities. They may have a general matrix of trade costs, which takes an unrestricted form. And we want to be able to say something analytically about the determinants of spatial distribution of economic activity. And then we want to try to take the model's predictions directly to the data. And so as I go through, I'll be mainly focusing on the theory, but also connecting to some empirical evidence as well. So what's the sort of motivation for thinking about this topic, for thinking about economic geography? Well, if you sort of think about the material we all cover in our core courses in economics, the location of economic activity in space plays a relatively minor role. It may crop up, for example, when talking about hoteling or in a number of other parts of the course, but it doesn't really play a big role. If you think about the world we live in, just being here in Jerusalem, looking around ourselves, we see that economic activity is extremely unevenly distributed across physical space in sort of radical ways. And that's most evident in the very existence of cities such as Jerusalem themselves. So for example, in 2016, more than 50% of the world's population were living in urban areas. That's projected to increase to around 66% by 2050, so particularly rapid change in developing countries such as India and China. Around the world, already by 2016, there were 31 megacities with a population of more than 10 million. And 24 of those are located in less developed countries. So really dramatic differences in economic activity. You also see that within cities. So for example, in New York, close to where I live, Manhattan has a population density of 66,000 per square mile. Staten Island, within the same city, has a population density an order of magnitude smaller, more like 8,000 per square mile. And then, of course, you go to Wyoming. Wyoming has a population density of 6 people per square mile. So dramatic differences in the density of economic activity. And some of those differences are obviously obvious. There are lots of mountains in Wyoming. It's hard to live on a mountain, but some of them might be endogenous to individuals' economic decisions, and that's what we want to study. And that concentration, you don't just see it for cities. You also see it for particular economic activities. So for example, the US manufacturing belt, which was concentrated in the Northeast and the Midwest in the late 19th century, and was one of the inspirations originally for Krugman's work. Dalton as a carpet manufacturing center in Georgia is another kind of classic example. And then obviously Silicon Valley and Route 128 more recently. So just to be a little more precise, what do we mean as economists when we speak about economic geography? Well, it's perhaps useful to think of kind of two notions of why the location in economic activity in space matters. So the first of those is perhaps the least interesting, what's often referred to as first nature geography. So what do we mean by that? Well, we mean the sort of physical geography of coasts, mountains, and endowments of natural resources. So obviously, some locations are different from others. Some have access to a deep natural harbor, are suitable for a port. Others are covered in mountains. It's much more costly to build on mountains. And so there are some very obvious reasons why economic activity might vary across space. And those actually are incorporated in most of our theories. So for example, international trade theory, sort of traditional Hectorone model, is obviously all about differences in endowments. And perhaps more subtly and more interestingly, economics also distinguishes what's often referred to as second nature geography. So what's the idea here? Well, the idea here is that the location of activity in space matters because the spatial relationship between agents matters. So what do we mean by that? Well, we mean the distance between agents matters in space because it may determine the costs of sending goods between them across physical space. It may determine the cost of migrating between those locations. And so it's the location of the agents relative to one another that matters. And that would be true even if the world were a featureless plane. And so that's the sense of economic geography that we want to study in more detail in the first lecture today. And of course, when we study that, we'd like to be able to say interesting things about second nature geography, even in a world where there are all these first nature differences. And that's very challenging, because it's challenging to this initial theoretical literature to allow for these differences in endowments and still be able to say sharp analytical things about the determinants of economic activity in space. And so our goal is firstly to kind of formalize why second nature geography matters, and then develop a framework where we can go to the data while also allowing for first nature geography differences. So I'm going to begin by introducing agglomeration forces and connecting back with this earlier theoretical literature by Krugman and Alphaman. Alphaman should really be giving this lecture. So we're going to start off with one of his models in the early theoretical literature. And so this early wave of research emphasized a particular microfoundation for the concentration of economic activity in space. It's often referred to as agglomeration. What's that microfoundation? Well, it arises from the interaction between three components. Love of variety, so consumers have tastes for many different varieties of differentiated goods, bless you. Increasing returns to scale, in particular of fixed costs, so average cost is falling in the quantity of output of each variety. And there are trade costs between locations. And those are the forces that are going to generate a mechanism for agglomeration. Of course, that's not the only force for agglomeration. It's been the one that's played the biggest role in the economics literature, particularly this recent quantitative literature. But I just want to flag that there are other reasons why you may think agglomeration might arise. So going back all the way to Marshall in 1920, he distinguished frictions between goods, people, and ideas. And those are sort of typically seen as the three key reasons for agglomeration. And in his language, frictions for people, economic activity agglomerates to pool the market for workers with specialized skills. So that's the people frictions, or agglomeration may occur to allow provision of non-traded goods in greater variety. That's the goods frictions, which are closest to this recent theoretical literature. And then the third set of reasons he gave were frictions for ideas, technological knowledge spillovers between agents. And just to flag for kind of ideas for further research, there's not been a lot of work to date really distinguishing between the relative importance of these three forces. And so in my second lecture today, I'm going to try to provide you some estimates of the overall magnitude of agglomeration forces. And there are several studies now which give us a relatively good handle on that. But there's still very little work convincingly distinguishing between these different mechanisms. And so sort of keep that in mind. Most of what we do is going to be focusing on this initial mechanism here. But there's a lot of interesting scope for work here, particularly with new sources of data like cell phone data, credit card data. We have a lot of new sources of data that might offer the ability to distinguish between these in more credible ways. Yeah, please. Mm-hmm.
Some of what Marshall was talking about, he thought of in the health context.
Absolutely.
Market for workers with specialized skills, that's going to touch on trade costs.
Absolutely. So yeah, great point. So one way of thinking about this more recent work by Krugman and Hauptmann is in terms of Marshall's three forces. One way of interpreting it would be in terms of the second force, frictions for sending goods, which is exactly about trade costs, goods trade, and variety. So that would very naturally connect with that. And as you also highlighted, you could also think about the market for specialized skills in a similar way. Instead of differentiated goods, it could be differentiated skills. And so absolutely. And so one way of thinking about this work is actually that it microfounds in a rigorous way some of the ideas that were already present in Marshall. Absolutely. So my first lecture today, I'm really going to focus on this modern literature, formalizing Marshall in a particular way, this intersection between love and variety, trade costs, and goods. Does someone have a question at the back? Sorry, I can't hear. Sorry. Yes. So good question. So you'll see in more detail how exactly I'm going to model this in a second. So I'm going to model this as love of variety, constant elasticity of substitution preferences. So in the sort of Dixit-Stiglitz tradition within microeconomics. And so the inputs aren't going to be literally non-traded. They're going to be tradable at a cost, at an iceberg trade cost between locations. But you could think of related models where some of the inputs are literally non-traded. And what might be an example there? Well, maybe it might be consumption of particular services that are very difficult to ship across geographic space because they require person-to-person interactions. So that might be an example of a non-traded input. Yeah, great question. So just think for a second why this combination of love of variety, increasing returns to scale, and trade costs generates a force for agglomeration. What's the economics behind that? Okay, well, there are going to be two sets of ways of thinking about that. Firstly, the presence of fixed costs of production, increasing returns to scale, is going to mean that firms want to concentrate production in a particular location in order to get the benefit of the economies of scale. Trade costs are going to mean they want that location where they concentrate production to be close to big markets. And that's going to be a first force for agglomeration on the firm side. And it's often referred to as a backward linkage because it's going from the market downstream backwards to firms' decisions. Okay, so that's the sort of first force for agglomeration. What's the second force for agglomeration? Well, it's going to be from the consumer side. Love of variety preferences mean consumers want to consume more goods. And trade costs mean they want to be close to the point of production of those varieties. Okay, and so that's often referred to as a forward linkage because it's going from the firms to the consumers. The consumers want to be close to where the firms are. And so as I'm sure you've already seen immediately, we now have this setting where we have a force where firms want to be near consumers and a force for why consumers want to be near firms. And those can obviously be mutually reinforcing. And so you see immediately that we're potentially going to have the possibility of multiple equilibria here. That if the world's a featureless plane, say just two regions A and B, if the firms expect all the consumers to be in region B and the consumers expect all the firms to be in region B, we may have an equilibrium, but then we also have another equilibrium where all activity concentrates in region A. And this early theoretical literature was all about formalizing that idea, how you can generate agglomeration, mutually self-sustaining decisions that can result in multiple equilibria, even if the world is a featureless plane. And I think someone had a question or no? And so what I want to do is I want to sort of start with those models that have that potential for agglomeration. And now I want to try to see how we might take them to the data, how we might make them more realistic. So instead of just having two symmetric regions that are identical or a featureless plane, we want to have many regions that are asymmetric in their productivity, their housing supply, their trade costs of one another. And sort of one very important thing to flag, how is this different from international trade? Well, the key difference between economic geography models relative to international trade is that people are going to be mobile. Okay? So in particular, the consumers are going to be choosing which region to locate in. So think of this as a sort of good model of states of the United States or regions of the United States where there's population mobility across locations. And that's the really distinctive thing about economic geography is that both people and firms can move and they can sustain these mutually reinforcing decisions. Just to flag that there is part of the trade literature which operates in a very similar way. Instead of thinking about people moving in space and the agglomeration of overall economic activity, there's also a literature in trade which thinks about the agglomeration of individual industries. And so, for example, Krugman and Venables have a paper in the QJE in 1995 which have many of the same ingredients, but it's a model of trade. And so people are immobile between locations, but intermediate inputs in that model play the role of one of the key agglomeration forces. Obviously, if we're thinking about the determinants of economic activity, if we only have agglomeration forces, everything is going to concentrate in one place, right? We may have multiple equilibria, but everything is going to concentrate in a single place because the only forces are forces for concentration. And so a key feature of this economic geography literature is that there are also going to be some offsetting forces that explain why everything doesn't concentrate in one place, why it doesn't all concentrate in New York. So what are going to be those dispersion forces? Well, in Krugman's original work, there was a sort of category of people, agricultural laborers, who were immobile, and the immobility of those agricultural laborers provided sort of a market in all regions in the economy. There was a sort of dispersion force for why firms might want to locate in backward regions and serve local agricultural workers. In the model that I'm going to develop today, there's going to be a different dispersion force, and that's going to be immobile land. There's going to be an inelastic supply of land in each location. And so as economic activity concentrates in one place, that's going to bid up the price of land, and that's going to be the dispersion force. Yeah, Paul, you have a question?
Yeah, I'm just curious to hear your views on, suppose that I was a trade person, more interested in macro trade. I want to understand aggregate trade flows across countries. Are you going to say something about what you're going to talk about, the spatial distribution of activity within a country, something that we might actually have consequences for this sort of international macro questions, or is that?
Yep, so great question. So in terms of answering that, I would sort of think about that in two ways. So one of the things I'm going to highlight in the model today is that the mobility of people changes the way you think about economic activity at the regional level. It's not quite your question, but it's related to your question. So in particular, for example, in trade, you know, there's this class of models where the Arcalacas-Costner-Rodriguez-Clare sufficient statistic for the welfare gains from trade holds. So what's the sufficient statistic for the welfare gains from trade? It's the trade elasticity of trade to trade costs, and the share of expenditure on your own goods in the open economy equilibrium. In models of economic geography, in general, the sufficient statistic at the regional level will be very different because of the mobility of people. So that's the sort of first step answering the question. The question you answered was actually not that, it was slightly a deeper question, which is that what if I don't care about the regions and I just aggregate up to the level of the economy? Do I need to understand the distribution of activity within countries to understand things about the nation as a whole? And the answer to that is it's going to depend a lot on the model. In some models, no. If you're only concerned about the aggregate for the economy, it doesn't really matter what's happening within countries. In other models, it actually matters. You need to understand the distribution within countries. And I'll try to say a little bit more about that later. But yeah, great question. Yeah, so yeah.
So natural endowments, do you think that in the faculty term, or I can recognize what that?
Great question. So when I develop the model, I'm going to think about it mainly as a, did you have something related you wanted to ask?
Can you repeat that?
Okay, do you want to say it a bit louder?
So natural endowments, the endowments of possibilities, is that something that appears to have to do, or is it something that's a non-thinking?
It's a great question. So when I develop the model, I'm mainly going to think about it in terms of productivity differences across locations. But you're going to see for some purposes, it's actually isomorphic, whether I think about it as a productivity difference or as a difference in the supply of land or housing, of an inelastic resource, of the supply of sort of land or housing. I'll show you that for some purposes, those two things are going to enter the model isomorphically. And they're also going to enter the model isomorphically to amenities. So if you think there's just say something nice about living in Israel because it's beautiful weather, you're close to the coast, for some purposes, these will all be isomorphic. For other purposes, they may have different predictions, and I'll try to highlight that as I go through. But yeah, great question. So let's get into the details. So how are we going to think about formalizing this idea? Well, I'm going to begin by developing the Helpman 1998 model, which was sort of initially in this theoretical literature with two symmetric regions, and we want to know when does economic activity concentrate in one rather than the other, or when do we have a dispersed equilibrium between the two symmetric regions. And then I'll show how we can actually generalize this, take it directly to the data, and we can still prove things about the properties of the model, like existence, uniqueness of the equilibrium, and so on, building on this sort of recent quantitative spatial economics literature. So we think of our economy as consisting of a set of n regions indexed by little n. And I'm typically going to use little n for the region of consumption and little I for the region of production in the lecture notes. Each region is going to be endowed with an endogenous supply of quality adjusted land or housing, HI. Obviously, in reality, you might think people can build more houses, that there can be a finite elasticity of housing supply. It's actually pretty trivial to generalize the model to allow a supply of housing to respond to its price with a constant elasticity. It's essentially going to leave most of the model unchanged, not flag where it would change things. The economy is also going to be endowed with a measure L bar of workers, each of whom has 1 unit of labor that's supplied inelastically with zero dish utility. And the key thing here, in contrast to a trade model, is that these workers are mobile across locations. And in the model I developed today, they'll be perfectly mobile. So obviously in equilibrium, each region in the economy that's populated is going to have to offer the same utility to workers. But again, I'll sort of flag, it's pretty easy to generalize this framework and allow for idiosyncratic heterogeneity, idiosyncratic preferences for locations. And for many purposes, it leaves the characterization of general equilibrium unchanged. Yeah, Eric.
Otherwise, you could buy it. You could build it smaller, put it on workers as you want.
Yeah, great question. So in terms of sort of whether you have multiple equilibria or a single equilibria is going to depend critically on how you think about this housing sector. The way we're going to develop the housing sector today is it's essentially just going to be Cobb-Douglas utility function. Utility depends on your consumption of goods and consumption of housing with a Cobb-Douglas functional form. And so as you pile up people in a location, the price of housing is going to go up, but the expenditure share on housing is going to stay constant by assumption. And as Eric is highlighting, things might be very different if you need a fixed amount of land in order to accommodate people, because then there's a limit to how many people you can pack in one region, and that might be another dispersion force in the model. At the aggregate level, there's some evidence for the US that this constant expenditure share is not too bad an approximation to the data, but in the limits, it seems implausible, right? As you really start to send the measure of people in a very small region to infinity, it starts to become a little bit implausible that everybody can live in an infinitely small amount of land. And so, thinking in more detail about that housing supply function is certainly a very interesting area for further research. I'm going to say more about that later, actually. So just to sort of develop that in more detail. But a lot of the literature assumes a Cobb-Douglas form because of track. Again, I'll sort of flag where that helps later. So yeah, great question. So these regions are connected by goods trade. So we can ship goods between the regions, but that trade is going to be subject to variable trade costs. And so that's going to be an element from Marshall, that there's a friction to trading goods between locations. And here it takes the form of Iceberg trade costs. So I'm going to have to ship D and I greater than 1 units of a good in order for 1 unit to arrive in the destination. So from I production to destination N. And so some of the good melts in transit. So as in the trade literature, we're assuming Iceberg variable trade costs. And again, another great extension is to really get inside this black box of trade costs. And so Murto Calipsidi at Harvard, who just won the Frisch Medal, she has a beautiful paper in Econometrica where she sort of tries to get inside this black box for trade costs. And there's a lot of other exciting work to do there as well. You'll notice the way I've specified things, I've assumed a symmetry of these trade costs. So it doesn't matter in which direction you travel. And so that might be natural if we thought these trade costs were just physical distance, which is symmetric. In other contexts, you might think these trade costs could be asymmetric. And again, I'll flag where that matters later. Symmetry is going to help, in particular, simplify the proof of existence and uniqueness. But actually, you can also handle the asymmetric case. It's just going to be a little more machinery you need to handle that case. So how about on the preference side? Well, we've already anticipated some of this. So utility is going to be Cobb-Douglas in the consumption of goods and in the consumption of housing, which is in inelastic supply. So this goods index for consumptions is actually defined over an endogenous measure of horizontally differentiated varieties. So this is the love of variety part of the model coming in. So if we think about the direct consumption index here in location N, the place of consumption, it's going to depend the sum across all regions I of production, the integral across the measure of varieties produced in each of those regions I, and then how much the consumer in N consumes of an individual variety J produced in country I. Okay, it's going to take the standard constant elasticity substitution form. Okay, so sigma equal to 1/1 minus rho is going to be the elasticity of substitution. And we're going to be concerned with the case where these varieties are substitutes. So sigma is bigger than 1, which we're obviously going to need to have positive markups in equilibrium. Okay. Key feature here is that M is going to be endogenous, and that's going to be a key, in fact, one of the most central ingredients of the model, and I'll be saying more about that in a second. And then obviously we can also define the joule of that, so the price index, the unit expenditure function, the cost of obtaining a unit of the consumption index, and again, that takes the standard constant elasticity substitution form. How about the production side of the model? Well, we want to have increasing returns to scale. That's going to be the third element. So we've now got all 3 elements of Marshall, some trade frictions for goods, love of variety, and we've got increasing returns to scale. And that's going to be part of our triad that's going to generate the forces for agglomeration. Because we've got increasing returns to scale that are internal to the firm, we need to depart from perfect competition. And so we're going to work with monopolistic competition. So we're going to take the sort of simplest form you can imagine for these increasing returns to scale. There's going to be a fixed cost of producing each variety. So we can sort of think of this as the cost of developing a blueprint for a new horizontally differentiated good. And so if a firm wants to produce XI units of variety J in location I, how much labor does it need to employ? Well, it needs to employ F units of labor to pay the fixed cost. And then it's going to have a constant marginal cost determined by the productivity of the region AI. And so related to a couple of the questions, this is a key asymmetry across the regions. This is a key element of first nature geography we've put into the model. So we've got second nature geography, love of variety, increasing returns to scale, transport costs, and we've got some first nature geography productivity differences across locations. Okay. And then the other element of first nature geography, differences in the supply of quality adjusted land. And the trade costs. They're going to be components, they may have components of physical geography as well. Where I've set things up, all these varieties J have exactly the same production technology, so it's a representative firm. But if you want to sort of have firm heterogeneity, LMLets, as long as you have a untruncated Pareto distribution, so truncated at the left side, but not at the right side of the support, everything goes through with a Pareto distribution. So in there, this is going to be a sort of weighted average of the varieties productivity produced in region I. So what is the producer of each variety going to do? Well, she's going to maximize her profits, subject to the downward sloping demand curve for her variety. So the usual form of the profit function, total revenue, price times quantity minus total cost, the wage times the fixed cost and the variable cost. So what are we going to get from the solution to that problem? Well, we're going to get some standard results that we're very familiar with. The producer of each variety is going to charge a constant markup over marginal cost. And notice the way we've set things up, because everything's symmetric, this markup is going to obviously be the same for all firms and just depend on this constant elasticity of substitution. Furthermore, all varieties produced in location I, again, because of the symmetry, they're all going to have exactly the same marginal costs. And then if we want to look at the price the consumer face, we just need to adjust the price at the point of production by these Iceberg variable trade costs.
W is wage.
Yes, W is the wage. Yeah, sorry, I should have flagged that. Absolutely, yeah. W is the wage, which is going to be endogenous in general equilibrium. And so one of the things we want to do is characterize that. And the other key feature of this model, which really helps and which makes everything so tractable, is we've obviously under monopolistic competition, we've got a zero profit condition. Okay, so if I substitute this pricing rule from the top of the slide into the profit function, and then set profits equal to 0. So in equilibrium, if there's supernormal profits in the region, more varieties are going to enter. That's going to shift the demand curve for every other variety inwards until we get to a monopolistically competitive equilibrium where we have 0 profits in equilibrium. Okay, so free entry of these varieties is going to drive profits down to 0. And plugging that pricing rule in the profit function, setting it equal to 0, we get this sort of classic result that equilibrium output of every variety is just a constant. That depends on the fixed cost, very intuitively. Firms are going to have to produce enough to cover the fixed cost of production. It's going to depend on the elasticity of substitution because that determines the markup per unit. And then it's also going to depend upon the productivity in region I. And now I know that constant equilibrium output of each variety. If I just plug that into the production technology, I can solve for the constant equilibrium employment required to produce each variety. And that just depends on these common parameters, the fixed cost and the elasticity of substitution. And you'll see that's really key to making it very easy to characterize the GE in this model. In particular, why is that? Well, it makes it very easy to work out the endogenous measure of varieties produced in each location. So in equilibrium, we're going to have a labor market clearing condition that requires the demand for labor is equal to the supply of labor, the supply of people who choose in equilibrium to locate in this region I. We know every variety in equilibrium, in a zero profit equilibrium, is going to be produced in a constant amount L bar, which just depends on sigma and F. So labor market clearing is that the endogenous supply of workers, capital Li, has to equal the measure of varieties produced in region I times equilibrium employment per variety. And then if I just plug in for that equilibrium employment per variety, depends just on sigma and F, then you see immediately we get this sort of classic result that the measure of varieties is just proportional to the supply of people who choose to live in a region. Okay, so that's going to make characterizing GE super tractable because we can just get rid of the mass of varieties and write everything in terms of the measure of people. And the only thing we have to worry about is the measure of people that choose to locate in an individual region. And for those of you who worked a lot on firm heterogeneity, you're probably already seeing why this generalizes in the case of Mellett's with a Pareto productivity distribution. And that's because in the Mellett's model with a Pareto productivity distribution, the mass of entrants is also just proportional to the measure of labor supply. And so you get a very similar set of expressions with a Pareto distribution productivity. Okay, so now let's try to work towards, that's just really characterizing the firm's problem and market clearing. Measure of varieties depends upon the measure of workers that choose to locate in a region. let's now try to work towards characterizing the rest of the general equilibrium. Well, in equilibrium, we need people to be indifferent across locations. So we need to say things about indirect utility, the wage over the price index, the goods consumption price index, and the price of land. So let's try to manipulate, get some results for that goods consumption index, that dual price index. Well, again, because of the CS form, that's just the sum across all locations I source varieties from. So the price index in N is the sum across all locations I, where I source varieties from. Because every variety is symmetric, I can replace the integral over the measure of varieties with just the measure of varieties times the price of each variety, power 1 minus sigma. And remember, we now know that this measure of varieties just depends on the labor supply. So we're going to be able to simplify the price index radically in a second. So in particular, if we substitute for the equilibrium pricing rule and the cost of sourcing a good in N from country I, and we substitute for the measure of varieties produced in I, we're just going to get this functional form for the price index down here. And you see what we've got here is the price index only depends upon wages and the measure of people that choose to live in the location. And that's going to be really helpful for characterizing GE because we're going to be able to characterize that solely in terms of wages and the measure of workers that choose to locate in each region. And notice this looks very similar to a trade model. We get a very similar expression in trade models. What's the key difference? Well, L is endogenous here, and that's going to complicate characterizing GE. We'll see how we can handle that problem in a second. So in an equilibrium, we're also going to have a goods market clearing condition that income in each country where varieties, or each region where varieties are produced, has to equal expenditure on the goods produced by that location. It's equality between income and expenditure in a world where trade is balanced, which will be our baseline assumption. So we also want to be able to say things about expenditure shares in order to be able to solve for that goods market clearing condition. And here again, results are going to look very similar to standard trade models. In equilibrium, what's going to be the share of expenditure in consuming region N on goods produced in region I? Well, that's just going to be the integral across all varieties I source from I. But again, because of variety symmetry, we can get rid of the integral and we just have the measure of variety sourced times the price of each variety to the 1 minus sigma. And then in the denominator, I'm summing all other expenditure on all regions. So this is an expenditure share. There's some common terms in total expenditure in the numerator and denominator, but obviously those just cancel. Hang on 1 second and I'll take the question. And so we get an expression for an expenditure share that looks very much like a trade model. And you're sort of probably anticipating what's the next step. Well, the next step is again to substitute for equilibrium prices and the equilibrium measure of varieties supplied that we just characterized earlier. And so we can write the expenditure shares solely in terms of wages and employment again. And then just before I take the question, just to highlight again, this looks very like an expenditure share in a trade model. What's the key difference? L again is endogenous, and that's the extra complication we need to work with. And sorry, I think you had a question in the middle. Absolutely, yeah. So one key feature assumption in the model is your flagging. So thanks very much for flagging that. Is that this elasticity of substitution is the same across all varieties, no matter whether I consume them from my own region or whether I consume them from other regions. In principle, as you're sort of implicitly highlighting, you might think an alternative assumption, maybe more plausible, is a sort of nested CES assumption, where perhaps the elasticity across varieties within my region is greater than that across regions. That's actually not too tricky to introduce. It will kind of complicate the sort of techniques I'm going to use in a second to characterize general equilibrium, but in principle, you can allow for that extension and go with a nested CES. You also might say, well, here you're leveraging a lot of CES, right? You're assuming that the sigma is the same for all varieties, it's constant. And so another interesting set of extensions is allowing for a variable elasticity of substitution. So maybe the elasticity for each variety depends upon the price of that variety and how much of the variety is consumed. And so Gianmarco Ottaviano, who I think is teaching later, may say something about this. He has a beautiful model in the International Economic Review with Jack Thies, where he uses quasi-linear preferences in one of these agglomeration models. And so that's another interesting extension of this class of models that's kind of important to keep in mind. Yeah. So great question. So to get this force for agglomeration, you need imperfect substitutability. There's a kind of a sort of classic result in the geography literature, kind of folk theorem in the geography literature. If you're in a world where you have both perfect substitutes and constant tensor scale, location becomes completely irrelevant, right? Because the technology is divisible. I can just, it doesn't really matter where stuff is produced. I can cautiously split production up into very, very small. So if I have a small location, I can just split production up into a small level of production for that region. And so how are we getting beyond that folk theorem here? Why does location matter here? It's because of this love of variety and increasing tensor scale. The love of variety comes from differentiation. These are imperfect substitutes. And the increasing tensor scale means like, I don't want to have this backyard capitalism where I split production up into small units because I've got these economies of scale. I want to be able to reap those economies of scale and cover the fixed costs. So yeah, great question. Yeah.
Just to follow up on that, so we're not thinking about services that cannot be consumed in this information.
Yep. It's a great question. So in the sort of simplest version of these models, we have these varieties that are tradable everywhere, but tradable subject to these variable trade costs. And that's going to be one of our three elements of the agglomeration force. As you're highlighting, another way you could formalize this is you might have one good that's perfectly tradable across locations, and another good that's a non-traded service, can be only consumed where it's produced. And that, again, will generate an agglomeration force through the non-tradable services. And in some case, you know, in a sense, that's obviously just the limiting case of this model, right? Where we send these variable trade costs to infinity between regions and keep them finite within regions. And then you're going to get that model of non-traded services as a kind of limiting case of the model here. But yeah, great to flag that as well. Yeah. I think Eric had a question.
It seems to me that implicitly it's being assumed that there's no geography within a region. That is, it doesn't matter where you take this metric, but you could imagine in a city that it makes a difference whether you live in the city or the city.
Yep.
Has this been modified to accommodate that kind of internal geography?
Yeah, it's a great question. So yeah, absolutely. As you're highlighting, I've assumed that these iceberg factors domestically within the region are equal to 1. In actual fact, there's actually not much loss of generality there. That we could have allowed a DII within the region, and it's basically everything I say is going to carry through. There's just going to be an extra term in some of the algebra where I'm going to have to include the DII, your own domestic trade frictions. And you know, but the question you're asking also highlights a kind of deeper conceptual point, which I think is also very interesting to draw out. Which is that in a sense, if I think about trade costs and productivity, an increase in productivity, the AI in this model, is also isomorphic to a reduction in your trade costs with everybody, including yourself. Okay, so that's kind of another kind of deeper implication of the related implication of the question you're asking. So absolutely, you can allow for those internal trade costs of this iceberg factor. And then some deep level within the model, an increase in productivity and a reduction in the trade costs with everybody, including yourself, are going to be isomorphic to one another. But at an even kind of deeper level behind your question, obviously you might think that modeling this internal geography within regions itself could be very interesting. It relates to Paul's question above, right? Which is Paul's question was about at the aggregate country level, if I aggregate all these regions up, do I need to worry about the distribution across regions within the country at the country level? The kind of even deeper element of your question is you could ask the same question within regions. Is it valid just to summarize these trade costs within regions by a DNN, which may be different from 1, or does it really matter the distribution of activity within those regions? And again, that's really going to depend a lot on the structure of the model. Yeah, great question. Yeah, Paul.
To Eric's question, obviously, another answer is that there's a whole field that is trying to do that. Yeah, exactly. Could be blended here. Right?
Correct. And that's actually going to connect very nicely with the second lecture after lunch, actually, where we'll be going within cities and we'll be saying something about that. And one element within cities, which relates to this question, which is going to be different, is obviously here, when you're thinking about regions, it sort of makes sense that people can only move between, say, US states. They typically don't commute between US states. But obviously, when you get down at that very fine spatial scale, within cities, within Jerusalem, within New York, obviously there's a lot of commuting that goes on. And so that's where you're really going to have to think about that within regions. This model just is not designed to handle that. And so in the second lecture today, we'll be kind of developing a model that also allows you to take into account these people flows through commuting rather than simply through migration. Yeah, my question. Yeah.
So on the same point, Paul and Eric talked very much being done already. So the nice paper man here and for somewhere, somewhere.
Yes, from Harvard. Yes.
We're doing exactly this thing with
Cell phone
where
data.
the region is kind of
Waves
an
data.
address.
Yep.
And people need to decide where they commute.
Yep. Yep, absolutely. Yeah, there's definitely this very active literature within locations, and the paper you mentioned by Naomi and Samuel Peleg is a very interesting paper where they use Waze data or some routing data to look at travel movements within cities and how that influences commuting decisions. And in particular, they're concerned about access to amenities. I've also been doing some work in that area with smartphone data, where you sort of, in the second lecture today, we'll look at commuting between locations within cities. But as you're highlighting in your question, obviously the reason people travel within Jerusalem is not just to commute to work. You know, we all traveled to have dinner together yesterday evening, and so people travel to consume amenities. And so there's a lively literature trying to use smartphone data to study those other kinds of movements within locations as well. Yeah, great question. Yeah, question at the back. So you can consider the limiting cases of perfect competition if you get rid of the love of variety, so you send sigma to infinity, and you get rid of the fixed cost, you send the fixed cost to 0. If you have positive fixed costs within the firm, you can't accommodate perfect competition, right, because of Euler's theorem that, you know, and the constant returns to scale, the value of output is exactly exhausted to factor payments. So value of production equals factor payments. Under increasing returns to scale inside the firm, the value of production would be greater than factor payments. Okay, so you can't do perfect competition if you've got an internal increasing returns to scale within the firm. But again, there's kind of a deeper angle to your question, which I'm going to say something about more in a second, which is that so far we've developed this model of monopolistic competition. In some ways, this model of monopolistic competition is going to be isomorphic to a model where you have perfect competition, as you suggested, but the economies of scale are external to the firm. Okay, so I'll make that point in a second. And so if you want to sort of do everything I'm doing here in perfect competition, one way you can do it is make the economies of scale external to the firm. And then you can retain perfect competition in goods markets and have these external economies of scale. And so knowledge spillovers might be one interpretation of those external economies of scale. So yeah, great question. So we've sort of seen how we can get this nice expression for the dual price index down here. And now I want to kind of, and the expenditure share here, and we've got them written in terms of just wages and the population in every location. And those are going to be the two equilibrium vectors we want to be able to characterize in general equilibrium: the vector of wages in every region and the vector of populations in every location. I just want to highlight that we can also get another nice expression for the dual price index that, again, you're all going to be familiar with from international trade. If we look at this denominator in the expenditure share, we see that it's the same up to a constant as the expression for the price index down here, right? So if I use my expenditure share equation, I can substitute for this summation here in the expression for the price index. And that's what I'm doing down here. So I'm getting rid of that summation using the denominator of the expenditure share. And obviously when I do that, I can just put in the constants that were in the price index in both the numerator and denominator here. I'm not going to change the expenditure share. And so I can eliminate the summation and some of the constants in the price index equation. And you see sort of immediately this sort of very important Arkalakis, Costner, Rodriguez, Clare result in the trade literature. In trade models, as you all know, efficient statistical welfare is the domestic trade share, the share of your expenditure on yourself in the trade equilibrium, and the trade elasticity. If you know those two things, you can work out the welfare cost of autarky. Why? Because under autarky, your domestic expenditure share is 1. Okay, we see that here in the price index. And if I divide the wage by the price index, obviously the wage is going to disappear over here. And we're going to have a very closely related result. The welfare depends upon your domestic share of expenditure on yourself, pi NN. Okay, and so I've just used this expenditure share with yourself in making the substitution of the price index. And then the key difference from the trade literature, again, which I've been emphasizing, this expression here depends on population. In trade models, that's exogenous, but here it's endogenous. And that complicates the characterization of GE a little bit. And also has some interesting economics, as I'm going to sort of flag in a second. So finally, what else is going to have to be true in general equilibrium? Well, obviously, we're going to have a land market clearing condition. The demand for land is going to have to equal the supply of land. And so this is sort of an area of quantitative spatial models, which is still a little bit of a fudge in the literature, because I'm sure there are many fudges, but this is definitely one big fudge. So again, another area for lots of exciting areas for further research. So what's the sort of simplest way we try to sort of clear the land market and take these models to the data? Well, one sort of very convenient assumption that's typically made is that expenditure on land or housing by consumers in each location is redistributed lump sum to the people living there. Okay, why? At one level, you know, this is going to be very tractable. It's going to help us characterize the GE in a very simple way. On the other hand, this is also obviously deeply implausible. Why? Because the identity of people doesn't matter here. When you move to a region, you just suddenly get this flow of funds that's redistributed to you based on total expenditure on land in that region. Obviously, you know, people rent houses or they buy houses. Whether you're a buyer or a renter might matter for the impact of various shocks on the spatial equilibrium. And so one kind of super interesting area of research, a number of students are working on at the moment, is sort of thinking about that distinction between buyers and renters and thinking about heterogeneous asset models, say from macro, Ben Moll's work in macro, putting those kind of ideas into a spatial model is a kind of really exciting area for further work. Why is it difficult and why, you know, do we make this assumption typically? Well, the state space quickly becomes very large, right? Because in a heterogeneous agent macro model, the state space is across the distribution of assets. And that might be very high dimensional if we want to kind of approximate a continuous distribution of assets. But then in the spatial model, we've got that distribution in every region, and we've got people moving across regions. So you need to track that high dimensional distribution of assets across the whole sequence of regions in which individuals have lived. And so that's the big challenge in this literature that people are trying to make progress on. So that given this assumption, it's actually going to be very tractable to characterize the land market equilibrium. So what's the total income of the people living in location N? The measure of people living there, their average income per person. Well, that's just the income they get from supplying their unit of labor, depends on the wage. And then it also depends upon this lump sum redistribution of total expenditure on land. And here we're just using the fact we've got a Cobb-Douglas utility function, and so a constant share of income, 1 minus alpha, is spent on land. And so our sort of redistribution lump sum, what it buys us is that total income is just a multiple of total wage income. Okay. But you know, just to emphasize, this is not without loss of generality. Why? Well, in particular, this introduces a new pecuniary externality into the model. If I move to a location, I bid up the price of housing, and that increases the income of other people living in that location. And so, you know, this assumption is not without loss of generality. It's going to affect the relationship between the social planner allocation and the market equilibrium. And so now let's sort of use that result. One key place we want to use it is in the land market clearing condition. And in particular, because of our Cobb-Douglas structure, we know that total payments for housing, so the housing supply times the rental rate of housing, that's just going to be a multiple of total income, 1 minus alpha. And we've just seen that total income is a multiple of wage income. And so we get this very simple relationship between payments to housing and payments to labor. And we can just take the supply of housing, which is exogenous in the model here, over to the right-hand side, and we can pin down the equilibrium rental rate. Again, in terms of wages and population, so we're going to use that in a second to characterize the G. Yeah. Alpha is the Cobb-Douglas expenditure share in the utility function. Thanks for flagging that. Yeah, it's the expenditure share on goods and on housing. Yeah. Great, so we're getting towards a position where we can characterize the GE. Before I do that, I just want to highlight a couple of economic implications of the model and you know, highlight what another sort of key property we're going to use to characterize GE in a second. So what's that property? Well, as we mentioned earlier, because people are perfectly mobile across locations, in equilibrium, all locations are going to have to offer the same utility to workers. Okay, so the indirect utility in location N is going to have to equal some common level in the economy as a whole, V bar, across every populated region. And where indirect utility is income, which we've seen is just a constant multiple of wage income, deflated by the cost of living, which given our Cobb-Douglas assumptions, the cost of living is just the dual price index for consumption goods to the power alpha, and then the price of housing to the power 1 minus alpha. And so that's going to be a key property of the model we're going to use to characterize the G. One implication of that, well, using the expressions I've just been deriving earlier, we've got an expression here for the rental rate in terms of wages and population. And we've got an expression here for the price index in terms of wages, population, and the domestic trade share. So I can plug those into my population mobility condition up here. And I know income is just the wage divided by alpha. So I can also make that substitution as well. And then the terms in wages are going to cancel because I've got a W with power 1 in the numerator. And once I substitute for P and R, I'm going to have a W with power 1 in the denominator. And so the wage is going to cancel. And I get this interesting expression for the population mobility condition down here. Okay, why is it interesting? Because when I look in the cross-section across populated locations, it tells me that variation in the domestic trade share, the share of expenditure on yourself, must be exactly offset by variation in population, such that all locations have the same common level of utility. So what does that say economically? Well, imagine I'm a port, which has imagine I'm a transport node. I have low transport costs to everywhere else. So I'm going to have a very low domestic trade share. That's going to raise my utility because we've got a negative exponent here. Why does it raise my utility? Well, it's an inverse measure of your domestic trade share is an inverse measure of the access you have to other locations. So locations that have low domestic trade shares have good access to other locations. So they have a low consumption goods price index, and that makes them a very attractive place to live. So if you have a low domestic trade share, that raises utility, and that has to be offset by a higher population. Okay, so very kind of economically intuitive feature of the model. But manipulating that, we can get a kind of another insight that relates to Paul's question earlier. What if I think about the welfare gains from goods trade in this model? So what's going to be my experiment? Well, I'm going to do exactly the Acr experiment. I'm going to think about starting from an open economy equilibrium where I have positive trade costs, domestic trade shares less than 1. And then I want to go all the way to autarky, sending trade costs for goods to infinity. But I'm going to continue to allow population mobility. So people are mobile across these regions, but I'm just going to make trading goods prohibitively costly, which is the sort of Acr experiment. And then if I take indirect utility in a trade equilibrium with superscript T, and I divide it by indirect utility in autarky, I know the share of expenditure on your own goods under autarky is 1. So I'm only going to have terms in the domestic trade share in the trade equilibrium on the right-hand side. So all I'm basically doing is dividing this in the trade equilibrium by the value under autarky and using the fact that pi is equal to 1 under autarky. And what's the insight we get? Well, we get exactly the Acr formula in this first term. Welfare gains from goods trade depend on the region's domestic trade share. What's in the power? Well, it's the trade elasticity, just like in Acr. So sigma minus 1 is the elasticity of trade with respect to trade costs in this model, just like an Armington trade model. We adjust the exponent slightly because only some goods are traded. So that's a little bit of a new element. Alpha, we need to take account of the fact that housing is a non-traded good. But then importantly, we've now got this extra term to think about the welfare gains from trade. They also depend upon the change in your population. Okay, why? Well, that's again very intuitive. Suppose I have a low domestic trade share in the open economy equilibrium. That means a big welfare gain from trade through the usual Acr logic. Because I'm getting access to more varieties, my domestic trade share is lower, which is signaling in a real preference sense that my benefit from accessing these extra varieties is greater because I'm choosing to consume fewer of my own domestic varieties than another region. So that raises my welfare, but then the model says if I benefit more from trade through that channel, that has to be offset by a bigger increase in my population relative to my population under autarky. And again, that's because of this knife edge population mobility condition. We all have to be indifferent across locations. Okay. So first, kind of economic insight here, we've got this sort of new channel, how goods trade affects regions. Population mobility has to adjust so that everyone's indifferent across all these locations. We can also get some other nice economic insights from this population mobility condition down here. I can also take population over to the left-hand side and take this sort of constant over to the right-hand side. Obviously then just raise the whole expression to a power. And what do I get? Well, I get this term in the numerator here. And then I can just sum up population across all regions. So take the summation of the LNs. That's obviously just going to equal L bar, the total supply of labor of the economy. And then on the right-hand side, I'm going to have the summation of this term in the numerator. And then that common level of utility, V bar, is going to cancel from the numerator and the denominator. And I get this nice elegant expression down here for the equilibrium population share of every location. So what does the population of locations depend on? Well, it depends on first nature geography that we started with, exogenous differences in productivity, and then related to your question earlier, you see here housing supply enters isomorphically to productivity if I'm only worried about population in the model. But then my population share doesn't just depend upon those first nature geography elements. It also depends on second nature geography. What's the sufficient statistic for second nature geography here is my domestic trade share with myself. And that's again because it's an inverse measure of market access. If I have low trade costs to other locations than another region, in equilibrium, I'll consume a higher share of other varieties in another region. That leads to a lower domestic trade share, and that's signaling that I'm a more attractive place to live, and hence I have a higher population share. So those of you who are familiar with the discrete choice literature, as I'm sure you all are, probably looking at this expression, will think, well, this just looks exactly like the expression in a Frechet model of discrete choice, or in a Logic model of discrete choice. And that's why it's sort of essentially trivial to extend this model by having a kind of idiosyncratic preference heterogeneity, so that each individual worker gets an idiosyncratic preference draw for every region and then chooses where to live. You're going to basically get exactly the same expression for population shares, but you're going to have an extra parameter, which is going to be the dispersion parameter of the extreme value distribution. Okay. And then connecting back with some things that Lorenzo probably talked about, that's slightly more complicated if you think about a dynamic discrete choice model. So I don't know if Lorenzo probably talked about that in his lectures. So there, workers start out in a region and they're choosing where to move. And so you have a kind of history to keep track of. The economy has a state variable, the number of people in every region. But nonetheless, you can use very similar techniques in dynamic discrete choice models. And so I've got a paper on my website called Dynamic Spatial General Equilibrium, which basically does proves existence uniqueness in a dynamic discrete choice model using very similar techniques. So that's another kind of nice insight we get for the properties of the spatial equilibrium. One kind of very exciting part of this recent literature on quantitative spatial economics is that although we've made these models very rich, we've got differences in productivity, differences in housing supply across locations, a general matrix of trade costs, they still preserve analytical tractability. We can still say something sharp about their analytical properties. And that was always a challenge for the earlier theoretical literature, just because of the nonlinearity of these models made it very difficult to get sharp, clean analytical results. And that was why the early theory literature focused on sort of symmetric locations to try to get some results. And so one very exciting part of this recent quantitative spatial literature is we've now been developing analytical tools, in particular Alan Arkalakis, their QGE paper in 2014, to be able to say sharp things analytically about the properties of these models. And so that's what I want to highlight now in this version of the Helpman model. So as we said, the general equilibrium, we can write it in terms of the vector of wages across locations and the vector of populations across locations. And so we're going to have two systems of equations that determine wages and populations. And so now I want to kind of derive those two systems of equations in terms of those vectors of the endogenous variables. And then any other endogenous variable I might be interested in can be written as a function of wages and population. So we're going to need to focus on wages and population. We're going to get one system from the population mobility condition, and then we're going to get another system from the gravity equation. And so let's start with the population mobility condition. So here at the top of the slide, we've got our familiar population mobility condition. And I've just rewritten it by taking the dual price index over to the left-hand side, and we've got our V bar, our common level of utility, in the denominator down here. Now I'm just going to rewrite it using some of those earlier expressions we derived. So we can write expected income in terms of wages. We can write, the rental rate for housing in terms of wages and population, and things that are exogenous, housing supply. So I'm just going to plug those into my population mobility condition. And then just to clean up the algebra, I'm going to define a W bar, which is just going to depend on parameters and this common level of utility. And notice here, there's a kind of choice of units here floating around. This V bar is going to depend on my kind of choice of units, my common units in which to measure common utility across locations, so choice numeraire or choice of units in which to measure things. And so that gives me this expression down here. So the price index in terms of wages and population. But then remember, I have another expression for the price index in terms of wages and population that we derived earlier, just from the standard sort of Dixit-Stiglitz expression for the constant elasticity substitution price index. And so I can plug that into the left-hand side here. And what do I end up with? Well, I end up with exactly what I was looking for. I end up with a system of equations in wages and populations. Okay, so what does that system look like? On the left-hand side, we've got a scalar, we've got a constant. And on the right-hand side in the numerator, we've got a power function of the wages and population of every location. And then we've got an operator, a summation across regions. And we're going to have a weighted average of the characteristics of those regions. What do those weights depend on? They depend on bilateral trade costs. That's the only bilateral variable down here. And then we've got a power function of wages and populations on the right-hand side. Okay, and that's going to be one of our systems of equations. Okay, so now I want to derive the second of the system. So where am I going to get that from? Well, as we were discussing earlier, in equilibrium, the income of every region is going to have to equal expenditure on the goods produced of that region. That's just the sum across locations n of the income in each location n times its expenditure share on region I. And then I just plugged in for the expenditure share, the measure of varieties, the price of each variety. And I've used the fact that the denominator of the expenditure share is a power function of the price index. And then recall, we had derived an expression for the price index earlier in terms of wages, labor supply, and the domestic trade share. So I'm going to eliminate the price index. And I've got another system of equations here. It's almost in the form I want it, but not quite. I've got a system of equations with a power function of wages on the left-hand side, an operator where the weights are bilateral trade costs, and then I've got wages on the right-hand side. It's not quite the form I want because I've still got the domestic trade share here, and I want to get it in terms of population and wages. So how am I going to do that? I'm going to use, firstly, we've got this expression for the price index here in terms of domestic trade share. And then from our population mobility condition earlier, we've got another expression for the price index. So I can put these two things together. And then I can rearrange and get an expression for the domestic trade share in terms of wages and population. Okay, so this is my expression down here, the domestic trade share in terms of wages and population. And so now I've got what I want. I can go back to my earlier equation here, and I can eliminate that domestic trade share, and I can get my second system of equations. Okay, and it's going to look exactly like the first system of equations. I've got a scalar over here on the left-hand side that depends on the choice of units. And then on the right-hand side, I've got a power function of the endogenous variables, so wages in location I to the power sigma. And then again, I've got an operator summing across locations, weighting them by their trade costs, and then a power function of population and wages on the right-hand side. Okay. So put those two things together. So this is the system of two n equations, which is going to determine the two n endogenous variables, the vector of wages and the vector of populations in each location. And so then you can show that under our assumption of symmetric trade costs, so dni is equal to dni, then the system of equations actually has this following closed form solution that I can sort of derive with the method of undetermined coefficients. That in equilibrium, wages and populations in our n locations have to be exactly such that this power function of them is equal to the scalar. Okay, so how can I confirm that's the case? Well, if I substitute for wages using this closed form solution here in this first system of equations, I get a system of equations in terms of population. If I make exactly the same substitution in the second system, I get an identical system of equations for populations. Okay, so in equilibrium, these wages and populations in each location have to satisfy this closed form solution. So I don't know whether that solution is unique or yet. And so how am I going to characterize that? Well, this is making that substitution. Okay, it's substituting for wages in one of the system of equations and determining, and then I end up with a single system of equations. And it doesn't matter which of these two relationships I pick to make the substitution, I'm going to get exactly the same system. And that tells me the endogenous population in every location n as a function of first nature geography, these exogenous things, productivity and the housing supply. And then the summation across locations of this operator, weighting by bilateral trade costs, and the populations in all locations on the right-hand side. Okay, so this is my second nature geography here. This is all coming through these trade costs in this reduced form of the general equilibrium system. Okay, so these sigma tilde, gamma 1 and gamma 2 are just derived parameters, so it's a little bit tedious, but if you just keep working through, you can simplify that system in the following form. What do I notice about this system? Well, on the left-hand side, I've got this term in ln sigma tilde gamma 1, which is identical to the variable on the right-hand side, except that that variable on the right-hand side is raised to this power gamma 2 over gamma 1. And so now we're going to use that to establish conditions under which the equilibrium in this model is going to be unique. And then we'll connect that back to that earlier theoretical literature on multiple equilibria that we were discussing earlier. Okay, so in particular, what's the result? Well, assume that sigma 1 minus alpha is strictly greater than 1. Okay, so what does that mean economically? It means that the housing share is sufficiently big. So 1 minus alpha is very big. Why is that economically interesting? Well, housing is a force for dispersion here. As you concentrate people in a region, the price of housing goes up. And it goes up by more, the bigger 1 minus alpha. So sigma 1 minus alpha bigger than 1 says that the dispersion force is sufficiently strong. What's the other element of the inequality? That's sigma. So why does sigma matter? Because it's part of the agglomeration force. It's because we have this imperfect substitutability that we've got this force for the concentration of economic activity. As sigma becomes very large, we start to approximate perfect substitutes. Okay, so again, a large enough value of sigma is going to ensure that this inequality holds. The agglomeration forces are going to become sufficiently weak as you make these varieties more and more differentiated. So if the dispersion forces are sufficiently strong, the agglomeration forces are sufficiently weak, then given the first nature geography characteristics, land supply, productivity, and then here I put a term in amenities just to highlight that you can also add an amenity, heterogeneity in amenities in the utility function. So you put a sort of an exogenous B parameter in the utility function, which captures how nice it is to live in Jerusalem, because we've got this glorious weather and we've got access to the ocean nearby. That doesn't really change any of the characterizations. So I just included that to make that point. And given those exogenous fundamentals and a symmetric matrix of bilateral trade costs, then there exists a unique equilibrium population that solves that reduced form system I just showed you. Why is it unique? Okay, well, we're just going to use the fixed point argument, first used in Fujimoto and Krauss, and then also used in Alan Markakis. So if we look on the right-hand side here, we've got monotonicity. Okay, so the right-hand side of this equation is monotonically increasing in the population of every location. And when sigma 1 minus alpha is bigger than 1, gamma 2 over gamma 1 is less than 1. Okay, so that's going to give us our fixed point argument that there exists a unique fixed point that solves this system of equations. And then related to some of the discussion we had earlier, I just want to now kind of highlight that although I derived this relationship in a particular model, namely the Helpman 1998 model, there's a whole class of models that are isomorphic. Okay, so if you think about this model, it has some special features like monopolistic competition, increasing returns to scale, as we were discussing earlier. An exactly same system of equations exists in a model of perfect competition and external economies of scale, as we were discussing. The system looks very, very similar. Powers are just going to be slightly different. And that's exactly the system of equation that Alan and Markakis look at in their 2014 QGE paper. So their goods are differentiated by location, called Armington differentiation in the trade literature, and it's perfect competition, external economies of scale. Exactly the same system of equations holds in the Eaton quantum model as well, with population mobility. So I have a 2016 paper on the reading list earlier in the slides, where again established an isomorphism for that class of models. So just like in the trade literature, we've got this isomorphic set of models where the trade share is a sufficient statistic together with the trade elasticity for the welfare gains from trade. There's an isomorphic set of models in the economic geography literature. You need some form of increasing returns to scale to get agglomeration force. Here it's love of variety, trade costs, and increasing returns to scale. But knowledge below those external economies of scale is another force you might have. You have a question down here?
Yes, I'm interested in the case of multiple equilibria. So
Yep.
imagine you want to study the situation in which this condition is not fulfilled.
Yep.
Do you think this is just not the right model to study that case, or is there anything we can learn for those systems?
It's a great question. You're ahead of me. That was the next point I wanted to make. So let me just speak to that directly now. So, this has been a big step forward in the quantitative literature. Why is it a big step forward? Because if I'm in the region of the parameter space where I have a unique equilibrium, I know I can say things analytically about what's going to happen in the model. If I say do a counterfactual, I want to build a new railway line between two regions. What's that going to do to the distribution of economic activity? Well, if I have a unique equilibrium, I can obviously say determinate things about what that does to the spatial distribution of economic activity. I can use the Decalque and Quartum exact algebra techniques from the trade literature to say things such as that. But if I'm not in that region of the parameter space, which is the region you're interested in, it becomes much more difficult to make precise statements for counterfactuals. Why? Because if sigma 1 minus alpha is less than 1, then generically the model has multiple equilibria. And many of those equilibria involve degenerate locations of economic activity where everybody concentrates in the region in which they concentrate is arbitrary, so they can concentrate in a range of regions. It's not completely arbitrary because we've got these differences in first nature fundamentals, but typically there's going to be a set of regions where economic activity will concentrate in. So the quantitative literature hasn't looked at that case, and the point I wanted to make is that's a super interesting area for research in this literature. It's really hard because you need a kind of regime switching model from, say, the econometrics literature. So it's developing tools to make interesting statements in quantitative models where you have multiple equilibria. And that's another kind of area really at the research frontier. I think it's kind of a super interesting area for further research. And there is a bit of a disconnect between this quantitative literature and the earlier theory literature, because the earlier theory literature was exactly motivated by the idea that space is symmetric and yet asymmetries endogenously emerge. We can have these multiple equilibria. That was exactly what Krugman was motivated by. And yet this quantitative literature has kind of gone in the other direction, and it's mainly focused on the region of the parameter space where you have a unique equilibrium. At a very kind of deep conceptual level, this is almost a kind of a philosophical debate, because what do I mean by that? Because if you think about the early theory literature, it was very stylized. These regions were exactly the same, no differences in productivity and amenities. Obviously, all models are stylized, and that was a particularly stylized model to try to reveal an economic force for agglomeration. The way we've written this model, I put a lot of heterogeneity in it, right? And so I've got these differences in productivity and housing supply and trade costs. And so one way of thinking about adding all that heterogeneity is it's describing the world in a more precise way, so that we no longer have a multiple equilibria. We're specifying the grains of sand in Krugman's language that determine, Krugman used these terms, grains of sand or expectations, tiny historical accidents in this early theory literature might determine which equilibrium you end up in. One way of thinking about what this quantitative literature is doing is specifying those grains of sand and ending up in this region of the parameter space where you have a unique equilibrium. But there is somewhat of a tension there, and I think developing methods to do the econometrics and do counterfactuals and multiple equilibria is a really interesting area, which I'm certainly very interested in, and I know several people working on. It's a great area for further work. I think a couple of further questions. Gentleman here, you haven't asked the question yet. Yeah, please.
Yes, I have two questions. So first, if we have these kind of edge cases of equilibrium where production concentrates in like one region because of the strong concentration forces, can we say something about if there's some kind of a mixed equilibrium where it's still nicely dispersed?
Yep. So in general, for a range of parameters, you can also support equilibrium where it's dispersed in some regions. And so the Acr paper I mentioned in the QGE, it fully characterizes that range of the parameter space, where you have some regions of the parameter space where the equilibrium involves complete concentration. There are other regions of the parameter space where you can support dispersed equilibrium. Again, it's going to depend critically on all of these power exponents from the CS system, the elasticity of substitution, and the share of housing in the model I'm developing here. But yeah, it's a great question. Yeah.
And so say that now I estimated the parameters. Once the counterfactuals, but multiple equilibrium. Like following up on Philip's question, should I introduce maybe further congestion forces? Like it is more likely that you could endogenize the entry cost?
So great question. So the way people have typically gone so far in the literature is they've gone in two directions. So one is to sort of add something extra, like as you suggested, such as congestion, to get back to the region where you have a unique equilibrium. So that's one direction you could go, or you could enrich the model further, inelastic housing supply, get rid of Cobb-Douglas housing, assume a fixed amount of land, the various things you could do to bring back uniqueness. That's one direction in which people have gone. The other direction they've gone is specify an equilibrium selection rule. And so in particular, the empirical studies that have undertaken counterfactuals in ranges where you have multiple equilibria, the selection rule they've implicitly used is when solving for a new equilibrium is to use the starting values from the existing equilibrium and then solve the system and update it until you reach an equilibrium. And that's not necessarily a unique equilibrium, but you're selecting based on the starting values you used in solving the system. But developing more rigorous methods to think about multiple equilibria, that's really super exciting area. I'd really encourage anyone interested in that to work on that. It's very interesting. Yeah, another question at the back.
Follow up on the
Yep.
If we believe that people are born in a certain location that is supposed to affliction.
Yep. Yep.
Do we still maintain the multiple equilibrium or?
Yeah, great question. So the paper I mentioned earlier on my website, the dynamic spatial general equilibrium. So we look at that case. So it's a slightly richer model because we also have capital accumulation. So we've got investment as well. And then we have exactly the dynamic discrete choice model of migration that you're envisaging. And you can characterize existence and uniqueness with very, very similar tools. Essentially, what the tools that you can work with is whenever you have a system that looks like this, where you have a power function of the endogenous variable, and then you have an operator or a kernel, depending on trade costs here, and then you have a power functions of the same endogenous variables. And in fact, it doesn't need to just be a system of populations. You can have extra systems as long as they all take this power form, and where there's a summation over the kernel and the power of the same variables. Again, you can use related techniques to prove existence uniqueness. And so we do that in the paper I mentioned. In general, the condition on the parameters is slightly different. So you're not going to get exactly the same parameter inequality. But if you're interested in following that up, it's the dynamic spatial general equilibrium paper where we prove that for a dynamic discrete choice model. So I'm a little low on time, but I want to make sure I just give you, say, a little bit more about empirics as well. So one, very useful feature of these recent quantitative trade models is this model is flexible enough to go to the data because I have many regions like we see in the data. They can have different productivities, housing supplies, trade costs. And in fact, these models I think have been influential for two reasons. One of them is you can sort of exactly rationalize the observed data as an equilibrium in the model. So if I give you observed populations, and I give you observed wages, you can in fact solve for the productivities and housing supplies in this model that exactly rationalize the observed wages and populations. And so when you go to the data, the model will match the data in initial equilibrium, and then you can do a counterfactual for, say, building a railway line between any two regions you choose. And so that's very, very useful if you want to ask kind of applied questions like, I want to build a high-speed line in California, what is that going to do to the spatial distribution of economic activity? And so that's one reason this literature has been very influential. Another reason is that it provides a micro foundation for a kind of very old idea in economics, which is that market access matters for the spatial distribution of economic activity. And so many of you may be familiar with the paper by Donaldson and Hornbeck in the QGE in 2016, which is within this tradition. And so, what is this tradition? Well, many people in the geography literature, and Harris in 1954 is perhaps the first person to do this, had kind of argued that where population concentrates in space depends upon the population of locations. And so he proposed a measure of what he called market potential, which is just the distance-weighted sum of populations in other locations. And he argued that this measure in the cross-section explains has a very high R squared for predicting the spatial distribution of economic activity. And so, that empirical correlation was out there for a long while, but like with the gravity equation in trade, it initially wasn't very intellectually satisfying. Why? Because we didn't have any reason why market potential specified in this way should be correlated with population. One reason it was deeply intellectually unsatisfying. What's the other reason? Well, the other reason is it's obviously an endogenous measure because it's saying when I regress my population on market potential, obviously populations are co-determined, they're determined jointly. You might think of unobserved variables that affect both my population and the population in surrounding regions. And so it was sort of deeply unsatisfying intellectually that it had a high correlation explaining the data, but it didn't have any theory foundations and it was subject to this endogeneity problem. So another reason these models have been very influential is they provided rigorous micro foundations for why market access might matter for the spatial distribution of economic activity. And they've highlighted areas where this ad hoc measure was sort of a little misguided, and the theory-based measure differs in a couple of important ways that I'll specify in a second. So in particular, how do these models provide micro foundations for market access? I'm going to show you that in the model, we can write the equilibrium wage in this model as a function of market access. So market access is going to determine income per capita in each location in the economy. How are we going to do that? Well, We're going to use our pricing rule. The prices are a markup over marginal cost, and this is the price at the factory gate here before trade costs. And we know equilibrium output of each variety is a constant. We proved that earlier. And what else do we know about output? Well, from CES demand, we know that the amount produced of each variety must equal the amount demanded in every market around the world. And so X bar, the quantity produced in equilibrium from the zero profit condition, it has to equal the sum across markets of the quantities demanded. And then what's the demand function? Well, it's just the usual CES demand function. The price, the amount sold is going to depend on the price. It's going to depend on bilateral trade costs, total income, and the price index. The price of competing varieties. How much I sell depends upon the price of competing varieties. So in what sense does this model imply a micro foundation for market potential? Well, I can define a theory-based measure of market access, which is often referred to as firm market access, which is exactly equal to this distance-weighted sum of market demands. Okay. And so I'm just going to define this. I'm going to call it firm market access. And when I make that definition, I can see that I can rewrite my equation equating total demand to the price, and it should be P to the minus sigma there. There's a typo there. I can take the P to the minus sigma over to the left-hand side. It becomes P to the sigma. Take the X bar over to the right-hand side. And I can see that my wage in equilibrium depends upon this theory-based measure of market access. And so these geography models give you some reason why access to markets matters. Why? Again, because of this love of variety, increasing returns to scale, and transport costs. But notice the model highlights why this earlier empirical measure was misguided. Why is it misguided? Well, it didn't control for wages for a start. It was only using distance-weighted populations. It didn't control for multilateral resistance from the trade literature, the price index. How much I sell depends upon the price of competing varieties. So there's a sort of two areas where the theory-based measure differs. And then in general, this is not 1 over distance, it's whatever your model of trade costs is. You might get that from a gravity equation, but the exponent is not necessarily distance to the minus 1. So that's sort of one key measure of market access that's sort of micro-founded by these theories. And then I've sort of highlighted a few papers in the empirical literature which have provided evidence for this relationship between market access and wages and other outcomes. Obviously, when we look at this equation, we've also still got the problem that market access is endogenous. So that still remains, even though we've theory founded it. And how have people solved that? Well, they've typically tried to find, say, natural experiments in the data that provide exogenous sources of variation in market access. So for example, I have a paper with Daniel Sturm in the AER in 2008, where we used the division of Germany as a source of variation in market access. So what's the idea? Well, in West Germany, there were these cities that were close to the center of pre-war Germany that lose access to markets in East when the Iron Curtain falls, and that Iron Curtain runs right next to these cities and separates them from their East German markets. In contrast with the cities in the far west of West Germany, they're much less affected by losing access to the East because they were much further away to begin with. They had much higher trade costs. And so we show that the predictors of our market access-based model have a lot of predictive content, even when you focus on that exogenous source of variation. As well as that measure of firm market access, this literature also highlights that there's another notion of market access from a consumer perspective. So the firm market access is the backward linkage I was talking about, from markets going backward to firms, going further upstream. The consumer market access is the forward linkage I was talking about, going from consumers to firms. How is that defined? Well, we're just going to start with our price index again, the unit expenditure function. What does that depend on? It's just the sum across locations where I source varieties, the measure of varieties I get from each location, and then trade cost adjusted prices. I'm just going to define that as my measure of consumer market access. And then obviously we see that the price index here depends on consumer market access. What's the economic idea? Because of love of variety and transport costs, consumers want to consume more varieties. That matters. Market access matters how easy it is for them to source varieties from other locations as determined by trade costs. And then I'm getting low on time, so let me just try to sort of flag the last 2 points I wanted to make in these lectures. The first point I wanted to make, for those of you interested in empirical work, is you can actually estimate these measures of market access in a theory-consistent way from trade data. So how do you do that? Well, in trade data, you see the value of expenditure of importing country N from exporting country I. And in the CS world, that just depends on total expenditure in the importing country, the price index, bilateral trade costs, price at the point of production in I, and the measure of varieties produced in I. And if I look at this equation, it's got the usual gravity form. Trade depends upon exporter characteristics, country I, importer characteristics, country N, and bilateral trade costs. And so I can just define a supply access variable, which absorbs all the exporter characteristics, a demand market variable that absorbs all the importer characteristics. And then I've basically got a gravity equation that I can estimate with fixed effects. I just regress bilateral trade on a full set of exporter fixed effects, a full set of importer fixed effects, and proxies for bilateral trade costs. And one of my proxies might be distance, and there I can actually estimate the coefficient of distance. And then I can include anything else that I think might affect bilateral trade costs. And then from the recovered fixed effects, which I know I can estimate in a model consistent way using Poisson pseudo-maximum likelihood, I can actually construct the theory-based measures of firm market access and consumer market access. And so that's the sort of first empirical point I wanted to flag for you. Anyone who's interested in following that up further, I've got a paper with Tony Venables in the JIE where we kind of implement that procedure using the trade data. And then the very final point I wanted to make is the sort of connection between theory and data. Is actually a point first made by Donaldson and Hornbeck in their 2016 PG paper, which is that I define these two notions of market access, a firm market access and a consumer market access. But if trade costs are symmetric, it turns out that those two are the same as one another up to a scale. Okay. And that's very closely related to the result we had earlier. Remember, we started off with these two systems of equations for wages and population. We established there's a power function relationship between wages and population, and we reduced everything down to a system for populations. A similar result holds for firm market access and consumer market access. You can just show using their definitions, and that's what the rest of the slides do, that they have to be the same as one another up to a scalar in a world where trade costs are symmetric. And so I just wanted to sort of end on that point to leave a couple of minutes for questions with further reading at the end of the lecture notes. Sorry for leaving only a couple of minutes at the end, but if there are any further questions, that would be terrific. Yep.
Maybe I asked a question, or maybe
anyone else want to ask who hasn't said anything so far? Eric? Okay, cool.
I was wondering, so here people want to live near terms want to live people, and I can see that for coffee shops, but not for factories. So I don't want to live too close to a factory. And I'm wondering if this is something that would change distribution or something.
Yep, great question. So it's actually interesting. When Krugman was writing, and Krugman and Ahonen were writing, they were actually very profoundly influenced by the concentration of manufacturing in the United States. So they were precisely motivated with the sort of, when you look at the map of manufacturing in the late 19th century, early 20th century United States, it's all in the northeastern states, say Connecticut, parts of Massachusetts, and then down into New York and in the Midwest states, as you know, Michigan, Ohio, and so on. And so I think one aspect of these models is well suited to think about that, which is that why was manufacturing concentrated in these places? And why in particular was New York a major manufacturing center? New York was the biggest manufacturing center in the United States if you look back in certain parts of the 19th century. Why? Because it was a transport cost hub. You had railways that were focused into nodes such as New York. You had ports where it was cheaper to ship things by sea, and that kind of gave New York an advantage. So one part of the model mashes very nicely with that, namely, increasing returns to scale in production, these big factories. I want to concentrate them where trade costs are low and where markets are big. And so there is an element that connects well with that. But as you're highlighting, there's also another element that doesn't. And how would I think about that? Well, I need to introduce these amenities that I mentioned earlier in the utility function. So it could be that when I concentrate production in, say, New York, that creates these dispersion forces. There's a lot of pollution there, and I don't really want to live next to a factory with a lot of smoke. And cities were not very pleasant historically. In particular, likelihood of dying was much bigger in 19th century British cities than it was in the rural countryside and so on, both because of disease related to something Paul's going to talk about this afternoon, and also because of pollution. And so that the model doesn't directly capture that here. but you could certainly introduce pollution externalities in here. And in fact, Walker Hanlon has some work along those lines where he's tried to do that for 19th century British cities. Walker Hanlon at Northwestern University. Yeah, great question.
But he could create a non-linearity because I want not to be too far from a factory because the trade cost, but not too close because so I was thinking like this tier system.
Right, interesting. Yeah, no, that could well be the case. One area where this model is not well designed to think about that is when I start to think about those questions, I really need to have a model where I can separate where I live and where I work, and I can commute between them. And right now we didn't allow that, but that's going to be very much the focus in the next lecture. And so we'll be kind of connected with things we think about later. But in principle, if you specify a very nonlinear amenity function, you could generate that force, but then you need to start thinking about commuting. Yeah, absolutely. So then I think Eric had a question.
That's a general question. You talked about resistance and the natural follow-on question. Analysis is what about efficiency?
Yep, so great question. There is that's been less research, but there is a related literature on that. In particular, there's a very nice paper by Fadjelboom and Galbert in the QJE in 2020, which develops a model related to this. It's actually slightly more sophisticated than the models I've been concerned with today, because they actually have two types of workers. They have skilled and unskilled workers, and they have them sorting across locations. And so they sort of show that within this class of models, you can also get some nice sharp predictions about efficiency of the market equilibrium. As Eric is anticipating, it's generically inefficient. Why? Well, there's a pecuniary externality on the demand side through manufacturing varieties, that as people move to a location, that makes it more attractive for firms to locate there, which makes it more attractive for other people to move to that location. So there's a pecuniary externality, which tends for concentration. The market doesn't take that into account. There's also a pecuniary externality through the redistribution of land rents. And then there are also pecuniary externalities through the price of land. And so generically, the market equilibrium is inefficient, and Pablo and Cecile's paper is actually probably the best paper to date, kind of thinking about those questions of the wedge between the market equilibrium and social efficiency. Cecile Galbert also has a very beautiful paper under revision at the AER at the moment on place-based policies, which is very closely related to Eric's question, because if you think the market equilibrium is inefficient, one way of responding to that is with a place-based policy. And so she has a very nice paper on that topic as well. And I think gentleman at the back, I think, had a question as well.
Yeah, the total number of housing is inelastic, but the region is elastic.
So great question. Absolutely. The way I developed the model, I had exogenous supply of housing. It's pretty straightforward to allow a constant elasticity supply of housing. So the way that's typically microfounded is, imagine I have a construction sector which produces housing, and it uses land and capital with a Cobb-Douglas functional form. And capital is perfectly mobile across locations, so there's just some common interest rate across all locations. Then what you can show is that that constant Cobb-Douglas construction sector implies a constant elasticity housing supply function. So the quantity of housing H is a constant elasticity function of the price of housing, where that elasticity is mu over 1 minus mu, where mu is the Cobb-Douglas share in the construction technology. And then when you get to the system of equations, you just have a slightly different power on housing here, which takes account of that mu, the share of land and capital in the construction sector. So if you're willing to buy a constant Cobb-Douglas construction sector, it's pretty straightforward to generalize this model to allow for that. In the paper on Berlin, I'm going to talk about after the coffee break, we actually use some data on property transactions to try to argue that a Cobb-Douglas construction sector is actually consistent with the property transactions data. So it's related to the earlier results. I have that the constant housing expenditure share is not too bad an approximation. In the micro property transaction data, at least for Berlin, it looks like a Cobb-Douglas construction sector is not too bad an approximation. But you could certainly enrich that technology, and you might think it's not Cobb-Douglas, and then that would obviously change the properties of this system as well. But if you're willing to buy a constant elasticity supply function, it's not too different to allow some upward sloping supply function. And obviously that's going to affect the condition for uniqueness, because again, you need that upward slope not to be too strong to get it in equilibrium.
Question that you take in the DI, the DNI is
Yes.
Imagine that there is a railroad. industry.
Yeah.
Or something like that.
Yep.
This model usually accommodate.
Great question. Great question. Yeah, that's a great question. That's been really hard in trade historically. So actually, I think Elhanan's PhD thesis, he had a kind of beautiful model where he modeled the transportation sector separately from the production sector and had different factor intensities in the two sectors. But much of trade and much of the geography literature has just gone into this iceberg formulation where implicitly trade and production have the same technology and the icebergs are exogenous, as Eric is highlighting. Why have people done that? Well, it's just super, super hard to endogenize them. But it's an area where there's been a lot of progress recently. In particular, Pablo Fagelbaum again with Eduardo Schall has a really beautiful econometrica paper in 2020, where they actually developed mathematical tools for doing optimal transport networks, for actually solving what the optimal network is and comparing that with the observed network. Historically, that had been a really challenging problem. Why? Because it's super high dimensional. I'm picking bilateral routes here, and that's very, very high dimensional. And I'm picking, routes that link together. I'm thinking of all the possible sequences I can follow. So it's very challenging numerically. And then also, typically, the problem is non-convex. And so they develop a methodology for convexifying it and hence for solving for the optimal transport network. They mainly focus on the planar solution, on the sort of market allocations. The best paper I know of myself is the paper by Murto Kalipsides that I mentioned earlier, where she focuses on the market equilibrium in the transportation sector, and she has a kind of taxi cab model of transport costs. So it's a sort of search and matching model. There are, in her case, ships. So they want to carry goods, but they have to match with firms. And then firms are looking to match with ships. And so like in the unemployment search literature, there's a kind of matching function that matches firms to ships. And she shows how to solve for the market equilibrium and how to kind of take that model to the data. They're the two best models I know, and I think it's a great point to highlight that. And again, that affects potential multiplicity, right? Because you might think one reason there are multiple equilibria is the transport network depends on where stuff's located, and that itself could create a force for multiplicity. So yeah, that's a great question. And then I guess we should probably stop there for coffee, right? I think we have a coffee break now.